some branching rules of thumb. These are going to help you in your way to becoming a great brancher in the assembly language. For every jump instruction that you use, ask yourself the following questions. This is very important. Is this jump part of an if statement? Is this jump part of a for loop? Is this jump part of a while loop? Or is this jump being used to break from the innermost loop? If your jump is none of this, you should probably not jump. It should also be some kind of a red alert for you. Maybe you are doing something strange or non-conventional, which is going to harm you in the future. So always make sure that you know which part of a higher level branching construct your jump is. Always be aware of this. Some words about reading code. Jumps by direction. Whenever you read code, maybe even your code after some time or somebody else's code, you should know that jumps forward should be if statements or break statements. And jumps backwards should be either for or while loops. So actually jumping forward is about conditionals and jumping backwards is about loops. And this is about how it's supposed to be. Besides helping you reading other people's code, this is a pretty easy way of remembering if you write it the right way yourself. You should be able to look at your code and see that jumps forward are conditionals and jumps backwards are loops or parts of loops. You may nest if, for, and while constructs inside each other. Actually, this is the big power of the higher level branching constructs. They allow you to do complicated things, but still be able to think about what you do at the same time. It allows you to divide your code into manageable chunks. You can actually see those constructs inside each other, and each one is going to have a meaning of its own. They are not just mixed together in some kind of spaghetti way. Another rule of thumb, which is pretty important, try to make sure that your jump passes do not cross each other. The best way to make your code unreadable to other people, and maybe the easiest one to do, is to make your jump passes cross each other. You don't want this to happen. Make sure that they do not cross each other. If you follow only the higher level branching constructs, this problem should be automatically handled, which means that it won't happen to you. Your jump passes won't cross each other if you use higher level constructs. So try to use those higher level constructs. Let's look at an example. Maybe you remember the first code that we have seen in the first slide, which was a very strange spaghetti code. Now that you know a bit about different kinds of higher level constructs and what could happen if you don't use them, you can easily note that there are many branches here that intersect each other. Also, that this piece of code is a bit hard to understand. Even though it is pretty small, it could take a few minutes to understand it, which is not good. This kind of short code should be very easy to understand. Let's begin by analyzing the code. I've just copied it to this brown box, and it might be a good idea for you to take a look at it yourself for a moment. If it is not very comfortable to you to look at the code in this fashion, you can just stop the presentation and take a look at the file spaghetti.asm, which should be included in your package. Take a few moments to read the code and to try to understand yourself what the code does. I will be waiting here. Welcome back. Let's discuss what the code does. The code begins by initiating ECX to 100 in base 16. Then what happens? We can see that there is some kind of loop here, because we can see this jump backwards, jump below looper, which jumps to this level. So we can at least see some kind of light here. We can see this loop. What is the work done inside the loop? We can see that there is some kind of printing inside the loop, which means that in every iteration, something is going to be printed. The thing that is going to be printed is actually the value of ECX. In every iteration of the loop, ECX is changing and its value is going to be printed. Indeed, we can see that ECX is increased by 8 in every iteration, and also there is some kind of comparison. ECX is compared to 130 in every iteration, and if that happens, which means if ECX equals 130, then we jump to a very strange place. We jump to this label to change ECX1, which is surprisingly here. It is very strange. It is outside of the loop. So we got here. Actually, so far ECX began from 100, and it was increased in every iteration by 8. And then at some point, which should occur, ECX became equal to 130. I remind you that these numbers are in base 16, and in base 16, 30 is divisible by 8. So this is actually going to happen. So when this happens, we jump to this strange place in the code, which is called change ECX1, which actually increases ECX by 1. And then it jumps back to this label. This is a pretty surprising part, a classic spaghetti. You jump to a strange place and then you come back. And then after coming back here to the go back label, we just move on as usual with the loop. So this is a pretty usual loop. It just loops from 100 to 160, but somewhere in the middle, ECX is increased by 1 in a very surprising fashion. This is pretty strange, but this is the code that we got. The output, as you probably expect, is something like this. I encourage you also to try to run this program and see this output yourself. The output is something like this. 100, 108, and so on, until we get to 128, which is just one iteration before the 130. If we added 8 to this number, we would get 130. I remind you that all of the numbers that you see here are in base 16. The next number, instead of being 130, becomes 131, because between the red part and the strange brown part, we increased ECX by 1. So now the loop goes on as usual, but there is some offset to the numbers. All those numbers were pretty nice, all of them were even, and the numbers here are odd, because we added 1 to ECX. We can see that the loop ends before we go over 160. Now that we basically understand the code, we would like to create some idea or pseudocode about structuring this strange code. we want to create a structured branching pseudocode, which is going to describe our basic idea of what this code does. But it is only going to use the loops that we know, the while or for loop, and only the conditional execution constructions that we know, which is the if statement. And all of these are going to be nested inside each other if we want to obtain more complexity. We are not going to cross our branches. They are going to be nested. So the code is going to be more readable. Let's take a look at some possible idea of implementing this kind of program. And this is, I remind you, just pseudocode. This is just idea of how we are going to build the final assembly code. Initially, we put 100 inside ECX. And this is just like here, like the beginning of the code. Now we are going to use a while loop. And this loop is going to iterate as long as ECX is smaller than 160. In each iteration, we are first going to print ECX. Then we are going to add 8 to ECX. And then there is a special case which we check with the if statement. If ECX equals exactly 130 in base 16, then we are going to increase ECX by 1. We are going to put ECX plus 1 inside ECX. And this is the end of the conditional, the end of the if statement. So actually we have here a big while loop, and inside of it we have an if statement. We already know how while loops and if statements could be implemented, and we can know ahead of time that none of the branches that we are going to have is going to cross another branch. That is because the if is self-contained with its branches. So if we translate this code into assembly, the branches of the if are going to be contained here. And the branches of the while will be contained inside the while. They are not going to cut the branches of the if. Now let's try to understand how to translate this code into assembly. I want to remind you that this part on the right is exactly the code, the pseudocode that we have just discussed. Take a look again. You see this part is exactly this code. I just spaced it a bit and put some colors so it would be easier to read the equivalent assembly code. As usual, I try to space it so that every line is the equivalent of the same line in the assembly code. Also, I added some colors to demonstrate the while loop and the if conditional. The first part is about initializing ECX, which is just like in the pseudocode. We just put 100 inside ECX. Then we get inside the while loop. We begin by printing ECX, which is going to be a bit more complex in assembly. We first copy ECX into EAX, and then we call the print EAX function, which is going to print EAX to the screen. Next we have this part. ECX is increased by 8, which is exactly the same in assembly language. And then we have the if construct, where we check if ECX equals exactly 130, and only if so, we increase ECX. And we have here this if construct. We compare ECX with 130 and check the inverse condition, the opposite condition, which is jump not 0. If there is no equality, we actually jump to the end if, and we skip the inner if clause. However, if ECX equals 130, then we execute this part, the inner clause of the if statement, which is about increasing ECX by 1. Finally, we have this part. All the parts that belong to the while loop are in purple. So this part, compare ECX 160, and then jump below, is just about checking if we want to do the next iteration. Maybe you have noticed that in some other examples we had the condition checking in the while loop earlier in the loop. Maybe, for example, in some other example that we have seen, we had this kind of comparison in the beginning. I just wanted to show you that you can have your own variations of it as long as you make sure that your branches do not cross. This basically is another piece of code which does exactly the same as the original one, but in my opinion it is much easier to read. I don't know what you think about it, but I hope that you think that this one is readable, and even more readable than previous code that we had to deal with. Just to compare the earlier code that we have seen and the new code, you can see that in the earlier code, the original one, there were so many intersections in the branches, and we had 4 different branches, which is very unfortunate for such a simple piece of code. However, in the new code, we only have 2 branches, and those 2 branches do not intersect each other. They are nested very nicely inside each other, which makes the task of reading the code and understanding it much easier than looking at this kind of spaghetti code. When you have to decide, always choose this kind of code, the simple one, over the spaghetti code. Some further improvement for the example. If you have time, in the end of the lecture, take a look at spaghetti.asm, which is the original code, and those 2 other files, structured1.asm, which is our first structured alternative to the original code, which we have just discussed, and then take a look at structured2.asm, which is another example of structured alternative to the original code. It is just a bit different, and maybe you will like it more. The difference between those 2 and which one is more readable is mostly about opinion. Therefore, I recommend you to take a look at this one too. You should note that in both of those examples, branches do not intersect, which is what it all comes down to. We don't want our branches to intersect. Summary. The jump instruction gives the programmer great power. However, it also gives great pain if it used without care. When using jumps, we follow structured branching constructs, which are if, for, while, and break. To make our code easier to read, for us and for our coworkers, and also to make our code easier to maintain. Some exercises. This time you are going to have a few exercises. They are pretty important because branching is really the basic of everything, of every kind of logic that you are going to have inside your program. Make sure to do all of them, one by one. Fight it hard if you have to, but make sure you understand how to solve those exercises. We are going to see some code reading, which is mostly about examples of using structured style branches. And even though they are going to be structured style branches, it is still going to take some effort to read those. Next, you are going to write some code yourself. After you got some inspiration from the code reading, you will have the opportunity to write loops, conditionals, and also nesting those inside each other. Finally, you will have a task of fixing a spaghetti code to make it more readable, however still do the same thing. So good luck with those and have fun.